Okay, yesterday we talked about making those graphs, those tables into graphs, and we would get equations for them, and they were linear regressions if they were straight lines, or what was the new one we just did? Quadratic. Quadratic regressions. And that's where it was quadratic data, and it makes basically like a parabola kind of shape. All right, that needs to go away, thank you. So what I want you to do right now is, if I gave you this data, would it make more sense to you if this is x and this is y? Would this make more sense as, 2 with 4 and 3 with 6? Would this make more sense as linear or quadratic data? Okay. Is it more like you'd multiply by something each time? In other words, if I said y equals, would it just be like some number times x? Would this be the right equation for it? Yeah, it would, because you go 2 times the x, and then you double each x, and then, okay, good. So is that linear or quadratic? That's linear. All right, so if I was going to make it quadratic data, what should the other side be? Like, well, 1's still 1, that's not much bigger. 2 would become 4, and 3 would become 9, and then it wouldn't look like 2x anymore. What would it look like? X squared. Very good. That's quadratic data. So if I give you quadratic data, would you know how to do the quadratic regression? Put it in, and then you just go to quad reg. Remember that? The hard part is, once you've got it, how do you figure out what to do with it? So let's say that we did our quadratic, and it didn't come out to be a perfect quadratic, so it had something like this in it, and then it had like that at the end. Okay, so say this comes out to me my answer for my equation. What if I then tell you that x is time and y is cars? You're collecting cars over time. Then I gave you, when will I ever get to 50 cars? Would you put that in for x or y? Y, and how would you do that on the calculator? Yeah, on the y equals screen. And then you'd graph both equations and see what they cross. What if I told you a time? At time 6. Well, and I just told you a what? An x value. And so you could go to second calculate the value. All right. Now that's enough review of that. Now let's talk about the new stuff. You may remember we started this unit with talking about what's a polynomial and what's not. The very first thing I taught you was, if you have a polynomial, it's something like this, y equals 6x squared plus 3x, etc. And I'd say, is that a polynomial or not? And the only rule for polynomials was that the exponents couldn't be fractions and they couldn't be negative. Do you remember that? So if I gave you this, y equals 6x to the negative third, that would not be a polynomial because it has negative exponent. So then that kind of begs the question, what are those things that have negative exponents or fraction exponents? And they have a special name. They're not called polynomials, of course. They are called power functions. This is a power, right? So this function has a power in it. So this is called a power function. And a power function has a few parts to it. The number in front of it, which can also be a variable, by the way. It doesn't have to be actually a number like 6. It could be pi. It's also a number, right? It could also be a number like k. Sometimes they define k as the constant. Okay, this part right here, that's called the constant of variation. And they use k for it. It's almost like we're Russian or something. The constant of variation. Okay, so that's the k. This is simple. That's the power. And I guess you could call that the base. And it's the constant of variation. It's spelled with a C. It's just that they use the letter K right here a lot of times for that constant of variation. All right. So if I give you this, y, and let's do a formula that you know. Area equals pi r squared. Is that a power function? Yes. It is a power function. Because why? Because it's got a power. You know how the other one, the monomials, they had this, or the polynomials, had this rule that they couldn't be negative and they couldn't be fractions? These can be any power except one thing, which is kind of like not a power at all. And what would that be? 0. They can't be 0, but they can be any other degree. So if I put anything up here, pretty much, it's going to be a power function, except these two things. Is this a power function? A equals 7. No. I at first thought it was because I remembered that other rule. This is a monomial. Because their only rule for monomials, if you hadn't already figured this out, you might want to write these down. The monomial rule, or polynomial rule, was that they couldn't be negative. It's not negative, is it? And they couldn't be fractions for the powers. It's not a fraction, is it? So that is a monomial. Is it a power function? No, because in a power function, it can be any non-negative number. Nope, I said that wrong. Any non-zero number. Okay, so since that's 0, this is not a power function. Because power functions can't have a 0 here. Any non-negative number. So one other thing that would screw it up is if it was like this. It's got a power, but the power is a variable. What's the word's definition again? Any non-what? Non-zero number. That is not a number. That's a variable. So you can't, this is not a power function. But almost everything else will be then. So if I give you like y equals r squared, as long as this is not 0 and it's not something weird like an x, it can be a fraction power, it can be a negative power, it can be a positive power, and this will be a power function. Yes?
Powers, like, could it be a power and a that isn't
This is a polynomial and it's a power. You are correct. Very good. All right. So if I gave you this formula, area equals pi r squared, is it a power function? Yes, because as long as the power isn't 0, it's okay. And as long as it's not a variable power. All right, so that's a power function. And what is the constant of variation? That. Pi. Pi is a set number, isn't it? That's not really a variable. So it's 3.14159. So it's just as if I had written this, except that I rounded there. But so yeah, this is the constant. And this is the power. The power is 2. All right, can you have negatives? Yes, you can. And they create something special then. And you need to understand how this works. If I say kr to the negative second power, if you have a negative power, did you know that that means the same thing as if I took this guy and moved it where? To the bottom and made it r squared. That is the exact same thing. This is equal to this. They're both the same thing. But in math, we usually say when you're simplifying a problem, you are not allowed to leave it with negative exponents. But in order to tell what is the power, it's better to use this, because you can see that the power is the power of -2. If you are judging based on this, you're looking at the wrong form of the equation, and therefore you can't tell me what the power is until you write it like this. Now I can say the constant of variation is k, and the power is -2. All right. So if I had 1 over m squared, I would not be able to judge whether or not that was a power function yet until I rewrite it as what? And 1m to the negative 2 is just m to the negative 2, right? And if I have this equation, is it a power function? Yeah, as long as it doesn't have a 0 for a power. And I also can't have a variable for a power. Like if I had said x here, that wouldn't be okay. It has to be a number. All right. Now let's talk about fraction powers for a minute, because I think a lot of you may only know one fraction power in your whole vocabulary, because I told you earlier this year. Does anybody remember what the answer to this question would be? 3. Because why? Because 1/2 power means the square root. All right, so I'm going to pause. All right, I'm back with you. So this is one of your common powers that you have to know. I'm going to make this a variable. Let's say r to the 1/2 power. Now, is that a power function? Yeah, what's the only thing it can't be? 0. Or a variable. Good. Is it a polynomial? No, because what's the rule for polynomial? Can't be negative and can't be a fraction. Okay, so this guy's not a polynomial, but it is a power function. All right, how about this one? Let's do volume. Volume is pi r squared h. Could I rewrite this in a different way? Yeah, this is also true. Pi h r squared, isn't it? Isn't that true? Same exact thing. It's just rewrote the order and multiplications commutative, so you can rearrange them like that. Okay, so then, is this a power function? Yep. The harder part is, what is k? Pi h. And they would have to tell you ahead of time, and they will in the directions, that, oh, by the way, h is a constant. They'd tell you that. Because to be a constant, this is not supposed to be a variable. But it says in the directions. It's right in the wording in the problem. By the way, we're going to define that h is a constant, and k is a constant, and m is a constant, and they'll give you a bunch of things in the directions that are constants. So this is your constant. That's your base, and your power is power 2. Okay, one more distinction between kinds. There's normal variation. That's like this. Kr squared. And then there's what's called inverse variation. Do you get that those two are very different than each other? Okay. You get I could rewrite the second one as k times, what would that be? R to the negative 2. Good. And obviously the black one there and the red one here are different. These are different. All right, so which one do you think varies directly, and which one do you think varies inversely? The bottom one varies inversely. This one varies directly. The way I can help you remember it is, do you get that an inverse is like 1 over something? It's a fraction. This has a fraction in it. The other one doesn't. So it kind of makes some sense that that would be the one that varies inversely. Okay. The way they'd say it in the book, when I read the book to make sure I was teaching this correctly, is they said anytime the power is negative, you're varying inversely. I'm used to seeing an inverse as like 1 over 8. That's the inverse. Actually, that's the reciprocal of 8. But anyway, an inverse is where you flip it and you put 1 over something. All right, so inverse to me kind of reminds me of a fraction. So however you want to remember it, you can just remember that anytime you have a negative power, or you can remember that if you're in a fraction situation, then you're varying inversely. Yes, sir. All right, 2 inverses are, okay, reciprocal versus inverse is the question. I'm going to pause for a second. All right, that is a good question. An inverse, so if I take the number 4, the inverse of that is negative 4, and the reciprocal of it is 1/4. And when I was saying fractions, I was thinking reciprocals, and it's really inverses that we're talking about now. So it's probably best to stick with the book's definition, which is that if it has a negative in the power, then it's an inverse relationship. Instead of direct, it's inverse. So there's two kinds again. I'll say them again. Y equals 6r squared, and then they might say this, y equals 6 over r squared. One of them varies directly, that guy. One of them varies inversely, that's this guy, because you could also rewrite this as 6r to the negative second. Oops. And inverse of 2 is negative 2. I guess that's a better way to say it than the whole fraction thing. This one varies inversely. Is that enough on that? Okay. It's not that bad. It's not that hard. If you have a negative power, you're not varying directly, you're varying inversely. Okay, I could show you real-world examples of that. It would take a long time. But basically, you know, like there's some things that don't go, every time something goes up, something else goes down. That's varying inversely. Like if the temperature goes up outside, then in our building, doesn't the temperature also go up inside? Yeah, so that pretty much is it's a direct relationship. If you had a situation where, oh, as the temperature goes up outside, something on the inside goes down, that would be varying inversely. Okay, I can't give you a good example right now. What if temperature on the outside goes up? Is there anything on the inside that goes down? What will go down as temperature goes up outside? Help me with this. Pressure? Maybe. It's a good guess. The amount of clothing people are wearing. Very good. So if it gets hot outside, people wear less clothes. That's generally true. All right, good. Okay, it took a little while, but we got something there. Okay, so let's actually do some practice problems like you're going to be having for your homework. Here's a typical question. They use f of x instead of y, which is fine. And they'll say negative 1/2 x to the 5th. And what if they asked you, is this a polynomial? And by the way, they'll start using the word monomial, which is one of the polynomials. But a monomial specifically has only one term. But it's still asking you that polynomial question. So is this a polynomial? Yes, because it's okay as long as the power isn't what? Negative or a fraction. Okay, good. And this one is then a polynomial and therefore is also a monomial. Is it also a power function? It is a power function. As long as the power isn't what? 0 or a variable. Okay, good. So this one is a power function, and then it'll say, if it is a power function, state the power and constant of variation. Power is 5, constant of variation, negative 1/2. Okay, that's a typical question. Let's move on to the harder ones, where they're going to ask you to write a statement as a power function equation. And it says, use k for the constant of variation if 1 is not given. All right. So the volume of a circular cylinder with a fixed height is proportional to the square of its radius r. Ooh, that sounds really scary and hard. But isn't that a formula you already know? I'm going to say it again. The volume of a circular cylinder. Remember my advice about word problems? Make a little picture. Circular cylinder. It's got a radius, right? What's this? Okay, and so what's the volume formula again? The pure form of the formula? Pi r squared. Okay. Now I'm going to read it again. Write the statement as a power function equation. Use k for the constant of variation if 1 is not given. And then the question says, write the volume of a circular cylinder with a fixed height is proportional to the square of its radius r. Isn't that the square of its radius r? Isn't that a constant? Didn't I write a power function? Isn't that a power function? Yeah. So that's it. I wrote a power function. Okay. Oh, sorry. Good point. Now, it's still, there's the pure form of my formula that I should have had in the first place. It's still okay. I just have to move some stuff around. Where should that h go? In front. I'm going to say pi h. I could have said h pi. It doesn't matter. R squared. And now this part is my constant of variation. Now, if in the directions they say that h is defined, it says at the very top here, C, G, K, and pi represent constants. C, G, K, and pi. Is that C, G, K, or pi? No. So that one's not necessarily a constant. A constant means it always stays the same. On a cylinder, is this always the same? The heights are always the same on all cylinders? No. Okay. Pi is always the same, isn't it? So pi is a constant. But this h is not always the same. So bottom line is, I have to do what it said, which was use k for the constant of variation if 1 is not given. So I have to use, instead of this, I have to use a placeholder, k r squared. No, because pi is a constant, but h isn't a constant, so I have to replace it with k. Okay, so the pi and the h I'm going to replace with k. I get that you're thinking we should have it as pi k. I don't believe I need to do that because together they will still multiply out to some unknown number. So I think I can replace both of them with a k. That's a good question. Would this have been a good answer? Could I have said v equals pi k r squared? And I don't know if there's anything wrong with that. This I know I like. This I think is okay too, probably. All right. I will be completely honest with you. This is my first day of teaching power functions. We've never taught it in this class before. Does that mean that, oh my gosh, this is going to be incredibly hard? No, we just haven't taught it before. So there's a few of these like on the edge questions where I might be like, I'm not sure. I have to look it up in the book. All right, so I'll find out the answer for that one, if that one would be okay or not. All right, moving on. Let's actually just hand this puppy out to you and get started together on this worksheet. Here you go. The reason we added it, by the way, is because we took off a really complicated process we used to teach that was called completing the square. And the calc teacher said, we never even use that, you guys. You don't need to teach that. And even though it was one of the things that was kind of cool, it made this class a little challenging, more challenging, we thought, well, we'll take that off and we'll put in power functions, which they do use in calc. So that's why we're changing in midstream from last year, is to make this class better preparation for calc. Okay, let's keep moving here. Number 1 I already did with you. Let's skip down to number 4. I want to remind you, if with a number like 13, that does not have an x, but, this is important, but it could have an x to the 0, because what's x to the 0 actually equal to? 1. So it doesn't hurt to add an x to the 0 if you want to. And that might remind you, can this be a power function? No, because why? Because you can't have a 0 for the power. So they ask you, is it a power function? And you'd say no. And then you say, why isn't it a power function? So because you can't be 0. No. Power not equal 0 would be a good shorthand way to say it. It sounds like the same you're supposed to tell why it's not a power. So I'm saying the reason it's not a power, maybe I should say no, not instead of no, is because the power can't be 0. All right, I'm going to move on to number 8. Question is it a power function or not? Is that one big constant? Yes, because pi is a number, and so is 4/3 is also just a number, and so therefore that's a constant. And is that a power that we can handle? Yeah, that's all right. As long as it's not 0 and it's not an x, we're good. So yeah, this is a power function. And that's the constant, and that's the power. Yes, on power functions, they can be fractions. Remember the only rule for power functions? They can't be 0 and they can't be a variable. All right, now let's move on to number 11 because a lot of people get confused because they think the directions are actually the exact same and they're not. On number 11, it says f of x equals -4. But the directions are determine if it's a monomial. That's not a power function. The question is it a monomial? Remember the rule for polynomials? What's the rule for polynomials? What about the power? Can a power be 0? Yeah. So this is a monomial. Okay, so back to let's try number 17. 17, in my 5th hour, I thought we had to do it a really complicated way. We did not. So let's just look at 17. And if anybody from 5th hour is looking on, I apologize. I made them do it a really hard way. Okay, it says the area of an equilateral triangle. Might be a good idea to draw your triangle. Equilateral means all sides the same. Okay? Area of an equilateral triangle varies directly as the square of the length s of its sides. Ugh, scary. But do you know what formula I should write? The pure formula? What's the area of a triangle again? A equals, what? 1/2 base times height. Okay? Now, would you agree that since I know it's equilateral, that I could actually write my height with a b? Maybe you know what I'm talking about. That distance right there, I could say it's some sort of a relationship to b because this side is b, this side is b, and this side is b because they're all the same, right? Okay. And then if I wanted to, I could make that other side, this side right here of my little triangle, I could figure that out in terms of b. It would be some fraction with a square root and then all that junk, okay? We don't need to have all of that. All right, the key here in number 17 is in the last part of the question. It says an area of the triangle varies directly as the square of the length s of its sides. We can trust them. We can do what it says. It says that it varies directly as the square of the length s of its sides. So it's saying we can skip all of that hard work of trying to figure out what the dotted line is. We could have done it that way, but it varies directly, which means in general, doesn't it have this form, k with something squared? And it says to use what? S squared. It says the square of the length s of its sides. And remember how it said in the directions, use k for the constant of variation if one is not given? It didn't give me the constant, so I can use k. All right. In the other class, I made them find the dotted line, and it's not impossible or anything, but use a squared plus b squared equals c squared. And you say this side right there is 1/2 of a b, and that's a whole b. And it ends up being the square root of 3/4 b squared. And then you can actually do it perfectly, and it's a cool answer, but you don't need to go that far. You just need to say, I don't know what the constant is, so I can put k. And it tells me to use s squared. 1/2 is a constant. Once again, I know you'd like to throw in a half here, and I don't think you're supposed to do that, but I'm going to find out if that's an okay thing to do. I don't think so, because it's thrown in with the other number, and we don't know the other number anyway, so we just call the whole thing k. But it's not just k. It's not just 1/2. It's 1/2 and something else, because with this length of the side is and something else. Okay, let's move on. Let's try number 19. Last problem, promise. Focus, one more. Number 19. The current I in an electrical circuit, I'm supposed to write a power function now, right? So how should I start? I equals is inversely proportional to the square of its radius r. What else is in the answer for sure? And I'm going to read it to you one more time. It's inversely proportional to the square of its radius r. It's got an r, I'll give you that. Then what else? Yes, you could either say inversely like this, or even smarter, just start with, instead of 1 over r squared, start with r to the what? There you go. And then what if I don't know that constant, which I don't? What do I put? Okay. There we go.
Are we allowed to leave it in like that, though? Which is negative last?
Yes. Yes, because we're trying to write power functions, we should leave it with a negative. When you're simplifying a problem, you're supposed to never leave negatives in the answer. You make a good point. But since we're writing power functions, we're supposed to leave them with their negatives. Okay, let's move on to number 21, just because I think you'll recognize some of the things. E is produced in a nuclear reaction is proportional to M, with the constant of variation being c squared. You know what formula we're talking about? E equals mc squared. But here's the catch. Number 21 is E equals mc squared. But read what it says. The constant of variation being c squared. Ooh. The constant of variation is the c squared. So that means I'm supposed to rewrite it the other way. Holy crap, it's been backwards this whole time. And then if this is the constant of variation, then what power is it really? If there's not a 0 on the or the m wouldn't be there. There's a 1 on the m. So its power is actually a 1. But you didn't know that. Okay, that's all I have for you for today.